We use the generalized quadratic relation in the form y equals a times x minus h squared plus k to demonstrate the properties of the graph of this quadratic relation. We need to compare this graph with the basic quadratic relation y equals x squared. On the basis of this graph, we can find out the change of this relation. We have known for this quadratic relation, the vertex should be the origin in the Cartesian plane, and we can regard x squared, its coefficient is positive 1, so the graph of this quadratic relation opens upwards. So the vertex 0, 0 is the lowest point. Alternatively, we can say it is the minimum value of this quadratic relation. For the y, this point, its y-coordinate represents the minimum value of y. According to this quadratic relation, we can find out for this quadratic relation, if a greater than 0, that you say the graph of this quadratic relation must open upwards. So we say parabola open upwards. In this situation, the vertex should be the minimum point on the graph. If a less than 0, the parabola will open downwards. The vertex represents maximum point on the graph. Okay, for this quadratic relation, we can find out the axis of symmetry of the parabola should be the vertical line. This line can be represented by this equation that you say x equals h. We say this vertical line x equals h represents the axis of symmetry. Okay, now if you plug in x equals h back into this generalized expression, x equals h, a h minus h squared plus k here equals 0, so y equals k. That will say x equals h, y equals k. This is the vertex. This is the vertex for the quadratic relations graph. So this point, whose coordinate h, k, represents the vertex. Of course, this graph assumes a greater than 0, so the graph opens upwards. Alternatively, if the graph opens downwards, the vertex represents the maximum point of the parabola. Next, let's examine the vertex. Its coordinate should be h, k. This vertex h, k, representing a horizontal translation of h units and a vertical translation of k units, comparing with y equals x squared, that is to say, compared with the parabola of this quadratic relation. So, in summary, we know the green curve represents this parabola compared with the basic parabola. We say the vertex should be moved horizontally by h. Here we assume h greater than 0, so the vertex will be moved to the right. K, representing the vertex, will be moved upwards by k. Of course, here we assume k greater than 0, so h is to the right of the origin. K is above the origin, so this point, this vertex is above and to the right of the origin, open upwards, so the vertical line representing the axis of symmetry. For this quadratic relation, you will find out the y-axis, that you say x equals 0, represents the axis of symmetry. That you say, for this quadratic relation, y equals x squared, we can rewrite it as x minus 0 squared plus 0. Here, a can be regarded as positive 1, so the vertex can be figured out like 0, h equals 0, k equals 0, so 0, 0. This point is the vertex of the basic quadratic relation, and this vertex is just the origin in the Cartesian pool layer.